Good afternoon to the conference chair and to the conference attendees and fellow professors and doctors and students of the research committee for this ACTAS. It is a very good privilege for us to be, for our papers to be accepted. I'm going to present in on the topic, which is paper 59, on the topic of the adoption of smart traffic systems to reduce traffic congestion in a smart city. So my fellow co-authors for this particular paper, they are Fumla Mabuza, myself, Oluwasegun Julius Aroba, and Dile Mabaso, and Fitokutle Sibisi. So all of us, we're actually based in Durban, the University of Technology, and which is based in South Africa. And permit me to move ahead because I know we haven't got more time in the conference. So when you look at a smart city adoption in another way, because in the year 1896, one of the most significant years for the world is during the days of Henry Ford, who actually looked at creating a new innovation of how to control and how to design and assess the car, the very first ever car in the world. So it scaled through the production in 1908, and traffic congestion now becoming increasing because car started coming into play. And traffic congestion has increased tremendously over that period. And it is the biggest problem in large cities around the world. And I'm pretty sure the traffic system is actually congestion is another thing in your area as well. So cities across the world have suffered greatly from different traffic congestions. Even the governments are also trying to harness the power of today in terms of computing them and also networking and also communicating this technology so that they can be able to build the system in different ways to improve the efficiency and the current traffic system with the conditions within. For traffic controls, there has been a lot of releases of successful traffic organizations across the globe, and the reduction of traffic congestions and environmental improvements, accuracy, traffic flow is very essential because some of these has not actually been looked into in-depthly. The current study that we're actually talking and presenting about is going to be considering a comprehensive investigation of the literature with analysis of types of studies, categorize the approaches used in the past in terms of the advantages and disadvantages. And these studies, at the end of the day, actually we evaluated to find the similarity between the content and benefits of how we can be able to apply those our project management skills in terms of using the SQUART process model, SQART model, to evaluate and prioritize this with the current state of the art. So this has actually helped us to be able to now finalize the on-road sensor and performance metrics that were used to analyze these projects. Permit me to go to the next slide for us to go into details. So as I've mentioned earlier on, in the literatures, we've actually been able to discuss different terminologies, different approaches that have been used, different methods, different techniques that have been used in different cities. Cities all over the world can collect traffic system data from vehicles, including traffic lights, roadside sensors, and also they actually detect the RFID on time using different mechanisms to be able to help in harnessing this data that have been collected from different angles. So with these, receivers are always analyze these traffic controls and sensors to produce a real-time data. And when we in our next slide, we start looking at different methodologies that we use to be able to attend to this method with this approach. So what is the benefit or what is the beneficial method and how did it contribute to the findings of the research topic that we've talked about, and what is the main purpose of this, which I've actually mentioned within a brief. This research was actually, the objective is to adopt a smart traffic systems to minimize traffic congestion in a modernized smart city. That is the major aim of why we look at this topic, because we know that traffic systems, they are necessary to be improved because they should provide different benefits in terms of we reducing accidents that happen on the road and also to save life within the society. And this should also help the vehicles waiting time to take more and to be able to direct themselves in the appropriate manner with the use of different traffic systems that have been put in place in different urban cities. Lastly, To prevent traffic jams, there has been so many ease of flows, and the key element of having a lot of efficiency in intelligent traffic system is for us to be able to introduce and improve the algorithm that will be able to detect the congestion efficiently with minimal error. So I believe I've now been able to talk about the methods and also the benefits and the objective of our research paper. So the next slide, we're going to be discussing in-depthly about different approaches that have been used from different papers. So when you look at what we have on the screen, there has been an author, Hamad et al. In 2013. They look at wireless sensor networks, and their approach was them putting the nodes the sensors to be able to communicate together to receive information, to be able to switch and reduce the duration of these responses and connecting the issues together. And after their methodology, what we discovered that as an advantage from their approach is that it helps to reduce communication cost and also the power usage for those traffic systems in those different cities. And what is the disadvantage of their method? It can easily add a channel interference and security issues. Also, in 2014, there is Kao and Chen. They wrote about the RFID traffic systems and the Zigbee wireless network communication. And their method was be able to detect the tags that has been tagged to these RFID traffic systems to be able to receive, analyze the data on time. And what are the advantage of their approaches is that they were able to, they're scalable, it is reduces traffic systems, accident power, and also it also helps to minimize costs in terms of power savings. Low data transfer rates is another disadvantage which affects the accuracy because it couldn't help them to be able to analyze the data on time. So there is the Caesar as well. They look at the KNN methods, and the traffic system is being classified into different categories. They avoid congestion, average systems, and they use those inputs to be able to reduce the congestion time. But their major disadvantage is that they have unfair traffic control systems within their system. And also, to furthermore, we looked at Fan et al. The technology that they use or deploy is big data. They look at the sensor, they attach it to the vehicles and produce real-time data in terms of to save cost economically when it's been attached. And disadvantage of this is accuracy decreases and more vehicles are being added from time to time and hour to hour based on the world. And also, furthermore, we also looked at Camp 2017 et al. They also looked at the technology behind the wireless sensor network, WSN, three transmitters, and they looked at the receiver to be able to detect and classify this vehicle in different forms. So after this, they talked that they said from their paper that their advantage is that it helps them to put classification with high accuracy on time. But the major disadvantage that we came about with this is that it utilizes different directional antenna and increased cost of implementation over time. So we also look at Khan et al. The technology they adapted was adaptive architectural framework, and their method is using data mining techniques and machine learning algorithm to monitor traffics, monitor data in terms of no alterations, which is a very good advantage benefit to them. And their disadvantage is that new data sources will change over time because different data sources that are being plugged in into their system or into their current approaches of adaptive framework, it will change the performance of those data and the life cycle. Also, we look at Perez, Moreta et al. Who they use deep learning technology, and also we looked at the we looked at the other ones as well, and so on and so forth. So permit me to now discuss about the prototype design that we've proposed in our framework. So we looked at time. You know that traffic congestion has to do with time because if the waiting time for a traffic to change from color green to yellow or maybe amber or to red, depending on which city and which color you guys are using in the fellow countries, you will know that timing is very, very important because the system is meant to be delivering time within a month, within a 2-month period based on our delivery and estimation for the prototype that we designed. and when we analyze this. And the scope of this delivery is that the system will be able to reduce the average waiting time and traffic congestion through the use of artificial intelligence and capturing all this data, and will now be able to send it to a system, to a database, or do I call it a data warehouse, where we'll be able to now access those data in terms of quality and do the data cleansing and data preparation and data analysis, so that the system will be able to enhance the version of existing model, and it will not meet the expectation of departmental or department of transportation, depending on which countries or which industry you're working at or you are. So what are the efforts that we've been able to look out for? Is that the research has been able to gather much existing forecasting systems that has been used in different angles. And the risk of this that we actually put here, which is, we talked about time, we talked about scope, we talked about quality, we talked about the risk and efforts. So if you look at what we have on the screen, we just said that the risk of this presentation is that the system may cause car accident should it malfunction, because we can't say a robot or a robotic system or traffic system is going to be perfect. If there is a redundancy in data, or if there is a switch in the light operation, or the power switch behind those, the traffic system it will tend to fail if there's no backup for solar or probably for any. So we call it as a risk, but we know that moving forward we'll be able to look more on this. This is our design, our prototype, as you've seen on the screen, as I've mentioned now. So if you look at what we have on the screen, looking at the four-way systems, we have different cars that can go based on their traffic model narrowing way in terms of start to stop, and we also wrote the code. We wrote the mini code on what's it called, on the compiler as well, which we can see our test code on the right hand on the screen. And I think I would not be able to, I'm not going to be able to have much time to explain that, but at your own leisure time, you can also take some time out to study the code that we've written for the traffic control forecasting. So to conclude this particular work of this research that we looked at, I would like to say that the report that we've been able to access from different forms in terms of traffic congestions, flow, we've not been able to effectively looked at or improving the of these functionality efficiencies. And also we've been able to determine the effectiveness of most important existence for TFF for regulating traffic control flow. And also the study also conducted a literature review, and we further investigate the purpose of efficiencies for intelligence systems to assess the performance. In light of all these findings on all our gaps and all the methodologies that we've been able to put together, it can be said that TFF possibilities are numerous. It involves various technologies and can be significant to reduce the majority of traffic issues in smart cities or urbanized cities. So, considering the environment that one is looking at, the camera sensors and the GP data, or all the data that has gotten from different methods or different locations, can actually be characterized or categorized so that it can shorten the travel times and lines to improve safety for prevention of accidents. On this note, I would like to say thank you very much for having me, and thank you very much for listening to our presentation. If you have any question, please do us a favor by sending it through the organizing committee, conference organizing committee, and we'll make sure we reply in due time. Thank you, and God bless you. Any question?